Hello, welcome to the A-level biology video. In this video, I'm going to be explaining the Hardy-Weinberg equilibrium. So, what is the Hardy-Weinberg equilibrium? Basically, it's this pair of equations that can be used to calculate the frequency of alleles in a population. So the frequency of homozygous, heterozygous, and dominant recessive alleles. So, we've got these two equations. It may seem a bit abstract at the moment, so we just need to try and explain what they mean. So firstly, we've got this one, P plus Q equals 1. So P simply means the frequency of the dominant allele in the population. That's the frequency of the dominant allele, and Q represents the frequency of the recessive allele. So what that's showing us is basically if we add up all of the dominant alleles and all of the recessive alleles in the population, it'll add up to 1 or 100% of that population. Simple so far. Next one, we've got this equation as well, which might look a bit more tricky, but what these mean are P squared simply means homozygous dominant individuals the homozygous dominant genotype. Q squared represents the heterozygous dominant genotype. Oops, sorry. Q squared represents the homozygous recessive genotype. Always good to put a deliberate mistake in there. So that represents the homozygous recessive genotype. And 2PQ represents the heterozygous genotype. So what we can see from this equation is that if we add up the frequency of the homozygous dominant genotype, homozygous recessive genotype, and the heterozygous genotype, that will also add up to 1 or 100% of the alleles in that population. Now this is good because all we need to know is one piece of information from one of these equations. We can calculate every other value. I'm going to show you that now. So I've got this question here that I just made up. So 5 out of every 1,000 babies are born with cystic fibrosis. What is the frequency of carriers in that population? So we can use these equations to work it out. So that figure, I just plucked that figure out of the air. It's not an actual figure, but we can use this as an example to help us calculate it. Now if you want to have a go at the question, you can have a go now. If you pause it, then I'll go through it afterwards. So, what we need to do firstly is work out what we know and what they want us to calculate. So, what they're trying to make us calculate is the frequency of carriers in the population. Now, as I'm sure you're aware, cystic fibrosis is a recessive genetic disease, which people will only get if they're homozygous recessive. But a carrier is someone who carries the disease but doesn't have it. So, in these equations, that would be 2PQ. They're the heterozygous individuals, they're the carriers. So what we're trying to work out from this question is this value here. That's what we want to work out. But we also need to work out what we have been given. So we've been given the proportion of people with cystic fibrosis, which would be Q squared, the homozygous recessive individuals. So the first thing we need to do is calculate Q squared. So simply we do 5 divided by 1,000 to work out the proportion of people who have cystic fibrosis, and that's 0.005. So that goes in Q squared. Okay. Now, from Q squared, we can easily work out Q, because all we have to do is do the square root of 0.005. 0.005 square rooted is 0.0707. So we've got two values there so far. The next one is also easy, because if Q is 0.0707, we can easily calculate P simply by doing 1 take away that. So 1 take away 0.0707 equals 0.9293. So that's P. So we've got some of those values calculated so far. So the next one that we can work out is p squared. So all we need to do is do 0.9293 squared, which will give us p squared. So times that by 0.9293 equals 0.8636. So that's p squared. So now we've got 4 of those values. We just need to work out the final one. This is the one that they want you to calculate. So there are a couple of ways we can do it. The way that I'm going to show you is this. We know what p squared is and q squared is. So all we need to do is take those values away from 1, and that would give us 2pq. So what I do is I do 1, take away p squared, which is 0.8636, and then I also take away q squared, which is 0.005. That gives me 0.1314. And that is our answer. That is the frequency of carriers in the population. So that would come out at about, obviously, 13%. And if they wanted you to work out an actual figure, so how many individuals would that be, you would times that by 1,000, and that would give you that value. So that's how we use the Hardy-Weinberg equation. Just a few points for me to emphasise here. First thing you need to do is work out what they've given you in the question, so which part of the equation have they given you. And the next thing you need to do is work out what they want you to actually calculate. So which part of the equation do they want you to work out? In terms of decimal places, obviously you need to be careful on that. We normally work to the same number of decimal places that they give you in the question. If they don't give you them, we normally do it to around the 3 or 4 decimal place mark for this type of question. Okay, thank you very much for watching. If you have any questions, please comment, please share this video among your friends, and please follow me on Twitter at RushcliffeBio. You can also tweet me if you have any requests there as well. Thank you very much.